So here we have a nucleus that we're slowly building up, and as we're adding more and more positive charge, we need to put our little neutrons in there. Notice they have no charge. And so as you're building, some nuclei will end up having too many positive charges to stay together for very long. So this nucleus is doing okay. It has too many positive charges. How do I know that? Because eventually the electrostatic force takes over and kicks something out. How it's going to kick some of that positive charge out as it repels against each other. And when it comes flying out, it comes out in the unit of an alpha particle. This becomes that alpha particle. It has 4 nucleons, and 2 of them are protons, and it comes zinging out. Zing! All right. So that leaves, what has happened is the nucleus has decayed. It's broken down. It's broken down in a type called alpha decay. Oops, there we go. So let's talk about what just happened. So I had my nucleus, my parent nucleus, as I'm going to call it. All right, and it had A number of nucleons and Z number of protons. Now let's write that. A is number of nucleons, and Z is the number of protons. All right, and so what ended up happening is it decayed and broke into an alpha particle that had 4 nucleons. 2 of them are protons. So then what's left? Well, this is called the parent, and this is called the daughter, and I didn't give myself enough space. We'll just call it D. So then 4 of those 4 nucleons left with the alpha particle. So the number I now here have A minus 4 due to what's called the conservation of nucleons. This is a horrible handwriting. Nucleons. So that means the number of nucleons you have on this side has to equal the number of nucleons on that side. And then down here, I have Z number of protons. 2 of them went with the alpha particle, so now I end up with Z minus 2 left. That is a conservation of charge. Let's take a look at what would that what's something a little more concrete. So let's take a uranium-238 nucleus. Uranium-238. Uranium's 92. Uranium-238 will undergo alpha decay. So 4-2 out it spits. So what am I left with? What's my atom here? So this turns into, I have 92 protons, 2 of them left. I have 90 left over. I had 238 nucleons, 4 of them were gone, so this turns into 234. This X, if you go to look it up on the periodic chart, becomes thorium. So this is thorium-234. Yay! All right. So, but look, I've got something over here and something over here. I've split up. I've got pieces that are together. I've got pieces that are apart. So what we can do is we can find out how much energy is released, because this thing comes zinging out. Where did that come from? Well, comes from the mass defect. So now we can find out, right? So that energy, the change in the energy is going to be the change in the mass times c squared. We need to find out what that mass defect is, which is then going to tell us our energy, which is my question for you tomorrow. How much energy is released? There we go.